Hello everyone. So today in this video, we'll try to understand how SSL certificate works. So I always had this question that um, what is the difference between HTTP and HTTPS? The usual answer that I used to get is HTTP is not secured while HTTPS is secured. How it is secured? HTTP HTTP does not encrypts the value when the communication between the client and server is happening, and thus it is not secured. While in HTTPS, when the client and the server sends value to each other, the value is encrypted. Okay. So, but I did not had a clear picture of how it actually works. So let us understand. Um, First, imagine that this communication between the client and the server is using HTTP. Okay. Now, let us imagine how it will do it. It will do, for example, the client wants to send a plain text ABCD to the server, and the server will receive it and it will send back a response in a plain text, say XYZ. Now, imagine uh, a hacker or a man, there is a man in the middle attack. So, there is some hacker sitting in between the client and the server, sniffing into the traffic. And when the client tries to send any data or the servers tries to send any data back to the client, this person sitting in the middle can read it clearly. Just imagine the client is sending some user ID password, right? It can easily get it and read it. And you obviously know, like it can be misused by this person. Now, what to do? The so the first thing that comes to our mind is let us encrypt the data before we send it to from client to server or from server to client. So in encryption, we have first the symmetric encryption. In a symmetric encryption, there is one key which is used to encrypt the data, and that key is used to decrypt the data, right? So for example, this client has a key. Okay, this client has a key. Hmm? With this key, it encrypts the data, sends this to the network, and if in between this man in the middle gets this data, then it will not be able to understand anything because the data is encrypted. But when just imagine when this data goes to the server will also not be able to understand the data because it does not have that key with which the data was encrypted. So it will not be able to decrypt it. Then what can we do? We can try to send this particular key to the server. And if we try to do this, just imagine that this particular key can also be copied by this man in the middle, by this person. And once this key is copied, it can use this key and we'll face the same problem. This man in the middle can read everything. So this is also not a solution. Now let us see asymmetric encryption. So if we use asymmetric encryption, in asymmetric encryption we have two keys, a public key and a private key, right? So the public key is usually used for encryption, and the private key is used to for decryption. So let us say the server has a public key and this server has a private key. What it will do, this server will send a copy of this public key to the client. The client will then use this public key, encrypt the data and send it to the server. And then the server can decrypt the data using its private key. Okay, so when the data is being sent is encrypted. For now, it looks very good, but Just think, this can also cause a problem because this person sitting in between, these are very smart people. They are very clever. They will find out a way to get our data. So how can this man in the middle try to sniff our data and read our data? Let us take an example. And so, for example, the server is trying to send this particular key to the client, and this man in the middle is acting as a proxy. As a proxy means whatever request comes from client, it will not go to the server. It will go from client to to this person, and then this from this person to the server. And whatever response comes from the server, it will first go to this person, and from this person to the client. So in that scenario, this when the server tries to send its public to the client, it will be copied by this man in the middle. And this man in the middle will have his own public key and will have his own private key. Okay, so it has copied the public key from the server, and what it will do is, instead of this public key, it will send its own public key to the client. Public key got its The client got its public key. It will encrypt the data using this public key and try to send it to the server, but that data will be caught by this person in the middle. And then what it will do, it will decrypt that data using its private key. After decrypting, it will encrypt the data using the public key it copied from the server, and then send the data to the server, and the server will decrypt it using this particular private key. The client and server will think everything is working properly, we have a secure connection, but actually the man in the middle is actually reading everything, so it's not secured, right? In this, to solve this problem, we have this concept of SSL certificate. So so the thing is, the server has the public key and the private key. So it is the responsibility of the server to generate an SSL certificate, a signed SSL certificate. To generate a signed SSL certificate, there are authorities, there are certificate issuing authorities whom the server will request to for this certificate, to generate this certificate for the server. So, for example, there is a mm, certificate issuing authority. Okay, this certificate issuing authority will have its own public key and also its own private key. Okay, so this certificate issuing authority will have its own public key and also its private key. When the server will request the certificate issuing authority to generate a certificate for the server, the certificate issuing authority will ask for the server's public key, and it will ask for it will ask for other details such as the domain name of the server, the country, the city, and there can be many other details which this server, this certificate issuing authority might ask from the server. With all this data, the public key, the domain name, and all the other data that it got from the server, it will take all those data and hash that data using a particular hashing algorithm. Okay, and that hashed value will then be encrypted by the certificate issuing authority with its private key. Okay, and this is how a certificate signature is created. Okay, this is with this signature the certificate is signed. Okay, and the certificate will be generated. After the certificate is generated, it will be sent to the server. So let's say this is the certificate, it is generated and it will be sent to the server. Now, so this is where our HTTPS starts, a secured connection. Now, at the very beginning, let us, what the client would do is, the client in the first step, in the step one, it will create a TCP connection with the server. Okay, this is the first step. The second step is TLS handshake. TLS handshake. In this step, the client would send a client hello to the server. In the client hello, the client would say that to the server that this is the TLS version I support. These are the um, like algorithms, hashing algorithms that the client supports, and things like that. The, information like that it will send to the server. The server would send a server hello back, and along with the server hello, it will send the certificate back to the client. Okay, it will send the certificate to the client. Now, this certificate the client has, and along with the certificate, it will also send the server's public key. Okay, now this is all fine. Now, let us imagine this certificate is caught by this man in the middle. Can this person manipulate this certificate like it was doing in the case of asymmetric encryption? Can it actually do it? So let us understand how the client validates this certificate. So how was the signature created by the uh, certificate issuing authority? It was created by taking all the details from the server, hashing it, and then encrypting it with his private key. Okay, this was my signature. So what would the client do? The certificate will have what? The certificate will have all the details like the uh, domain name and all these details, and also the server's public key. And what will the client do? The client will hash all this value. Will do this hashing with all the server's public key, domain, and everything, and will create a hashed value, and then it will use the certificate issuing authority's public key to decrypt that signature. So if we decrypt the signature, what you will get? We'll get that same hashed value that was hashed by this certificate. Now this client will match that two hashed value. If that hash value is matching, that means the certificate is valid. That means the certificate is valid. And before doing all this matching of the hashes, before that step, the client would also check if the certificate, what is the expiry of the certificate, who has issued the certificate. This also it will check. After that, it will check this hash. So this is how the certificate is validated. Now imagine this certificate is now copied by this person, man in the middle. If he tries to manipulate any data in the certificate, or if he tries to send its public key in place of the server's public key, and if he sends this certificate by manipulating it, then this certificate validation will fail here. Okay, and this is how the problem that we are facing with the asymmetric encryption is actually solved by this SSL certificate. So now we understand it is not possible for this man in the middle to actually manipulate the data. So even if it manipulates, it will the validation will fail here, right? Now, so first two step is done. TCP connection is made, TLS handshake is done, and the next step is key exchange. So what happens? Asymmetric encryption is heavier than symmetric encryption. It means asymmetric encryption is slower than symmetric encryption. Symmetric encryption is faster. Okay, so the actual data transfer happens between the client and the server using symmetric encryption. So for symmetric encryption, what we will have only one key for both encryption and decryption. So in the next step of key exchange, this client will actually generate a session key. Session key, session key is a key. What, like for example, when the TCP connection happens, when the TLS handshake, after the TLS handshake is done, it will generate the session key. This session key will actually be gone whenever the session is closed. So again, the session key needs to be created for the next session. So if you close the browser or something, the session key will be gone. Okay. So this session key will be encrypted with this public key. This session key will be encrypted with this public key and sent to the server. Okay. Now imagine if this encrypted session key is actually copied in between. Can this person decrypt it? No, because this person, man in the middle, does not have the private key of the server. And when it goes to the server can decrypt it using its private key. Okay. Now at this stage, both the client and the server has the has that one key for symmetric encryption, and this is called the session key, and this is called key exchange. Now after key exchange, the actual data transfer begins. Now imagine the client wants to send this particular plain text ABCD. Okay, this ABCD will be encrypted by this key. So when it is going, it will be some, when it is going to the network, it will be some garbage value, something garbage, some garbage value it will be. So even if this garbage value is copied, this man in the middle will not be able to do anything with this data because it's garbage to him. Okay. Now when this data is sent to this server, it will be decrypted. This value will be decrypted using this same key. And this is how the server will know what data is being sent from the client to the server. And the server, while sending back the response, it can encrypt that response, send it to the client, and the client can decrypt it using this key. So I'm hopeful that it was useful. This information was useful to all of you. And if you liked it, please like the video. Thank you so much.